Now, metric in Ospf. We know Ospf uses cost based on bandwidth. Cost is equal to 100 by the bandwidth. 100 is used as the reference bandwidth. For calculating the cost based on bandwidth, Ospf uses this algorithm so that it can automatically calculate the cost and find the best path. Listen. To provide you a best path, metric need to be calculated dynamically. We all know. And Ospf uses bandwidth and calculates the cost dynamically for you. See, I'm using the word dynamically again. Why? You know, there is another protocol which is also a link state routing protocol that will never calculate the metric dynamically. You know which one it is? ISIS. ISIS is the another link state routing protocol we have. Intermediate system to intermediate system, which will never calculate the metric dynamically. It will not calculate the metric. It will not calculate the cost dynamically. It won't consider bandwidth first of all, nor delay, nor maybe hop count. We'll talk about that when we go there in CCI level, when we learn ISIS. But now Ospf, coming to Ospf does dynamic path calculation, dynamic cost calculation. Based on bandwidth, they calculate the cost. And this is the simple formula it uses. 100 is the reference bandwidth divided by the actual bandwidth on the link. For example, so it's a simple topology I'm drawing, and you want to go to this network. Let's say this network is 1.1.1.0/24. Router 1, to reach 1.1.1.1, it can go via router 2 or it can go via router 3. It may take any one of this path. Right. So now, if it is a fast Ethernet, the cost is going to be 1. You know why? Because in MB it's 100 meg wire. So 100 the reference bandwidth, the denominator is the actual bandwidth. What is the actual bandwidth? 100. You get 1. That's how 1 is the cost. This is what dynamically calculated cost. Dynamically calculated. In case if you have Ethernet wire here, which is 10 meg, that will be what? 100 divided by Ethernet. You get 10. So cost is 10 here on Ethernet. Now Ospf will decide to go this path because cheaper. This one is costly. So far, do you have any question, Joseph?
No, sir.
Okay. Now let's go to the next level. Same topology. Here I got gig Ethernet. Here I got fast Ethernet. R1, R2, R3. Gig is 1000 meg. Fast Ethernet, as we already spoke, it is 100 meg. Now the formula, you know, its cost is equal to 100 by the actual bandwidth. Now for the gig Ethernet, (100 by 1000) is going to be 1 only. It won't take any fraction numbers. Cost cannot be fraction. (1 by 10) is equal to 1 only. It will seal it to 1. And for fast Ethernet, cost is equal to 100 by 100 is the formula, the numerator, the reference bandwidth, divided by the actual bandwidth. That is also 1. So Ospf here will think I have 2 paths. One this way, another way. Both cost is 1. And it will try to do load sharing. Equal cost will always do load sharing. Right. Now, this is not fair, you see. How can 1000 meg and 100 meg be same? For Ospf, both appear to be same speed because the cost is 1 for both. And now, if I, for example, if I have 1000 packets to send, it is going to send 500 packets this way and 500 packets this way. For you to understand, I'm putting this. Sending 500 packets here is okay, but sending the same amount to here is not good because the bandwidth is narrow. It's not wide like gig Ethernet. It's 10 times smaller. But Ospf cannot differentiate if the bandwidth is more than 100 meg. Listen, why? The reference bandwidth is 100. That's why. Because the numerator is 100 set. Any number above 100, even if it is 10 gig. 10 gig means what? There will be another additional 0. Even if you put these many zeros, Ospf will say this and this is same. For Ospf, it cannot differentiate because the numerator is 100. See, that numerator I call it as what? How the Ospf calls it as reference bandwidth. To refer, upper limit is 100. If you will change this reference bandwidth, then it is possible to differentiate this. But by default, this is the algorithm. You see, the default is 100 by the bandwidth, actual bandwidth on the interface. 100 divided by bandwidth on the interface. So if you are depending on dynamic bandwidth calculation, you have to face this issue. When you have any link, more than 1000 meg, more than 100 meg, Ospf cannot do fine justification. Ospf cannot differentiate. Did you understand the problem up to now?
Yes, sir, got it. Yes, sir.
So there are two ways to solve this. One, you go to the interfaces and assign the cost manually. You say, I don't want to consider the dynamic calculation. I don't want this cost. You don't calculate. I'll give you the cost. You do like that. So you can manually configure cost like this. You go to the interface and say, this is the cost. So what you can do, you can manually go and say, cost here is 1, cost here is 10. When you manually do that, now Ospf can differentiate it. This is one way. Second way is, this is the default formula, 100 by actual bandwidth on the link. 100 is the reference you are using to differentiate. That numerator you change. This reference bandwidth you change to some big number, like if you make it as 10,000 by bandwidth, now it is easy. R1, R2, R3. Now it is easy. You see, I got like, let's say 10 gig link, 10 gig, and I got 1 gig link, and I got another link, let's say 100 meg for the backup. Now let's see the calculation, the cost. If it is 10 gig, the cost is equal to 1. So the cost here is 1. And for 100 meg, the cost is equal to 100. And for 1 gig, the cost is equal to 10. See? Now Ospf has become clever protocol. It can now choose this path as the best path. If that fails, this is the second best path. If that also fails, only then it will come to 100 meg path. See how easy it is? Just change the numerator. So do like this, or go and change the reference bandwidth. I was taking 10,000. You may take anything up to this level. Very big number. I don't know whether we will reach this big number as a bandwidth anytime. It's like 400, not 400, I think 4,000 gig, something like that. Big number. Anyway, we are going to now quickly do the lab to understand this one more time better, and I'll close. So I have taken 1 gig Ethernet, 1 fast Ethernet, 1 serial. For gig Ethernet, I would like to give IP address 10.12.12.0/24, and for fast Ethernet I would like to give 10.12.12 21.0, and for serial I wish to give 10.21.21.0. So three different networks we have taken. And we are going to run Ospf for testing behind router 1. For testing behind router 1 and router 2, I am going to take loopbacks. Ospf metric Ospf metric is enough. Now we got these two consoles ready. Let's quickly configure the basic thing using Notepad. Enable config T interface serial 6/0 IP address 10.21.21.1 255.255.255.0 no shut IP Ospf1 area 0 interface F0/0 IP address is 10.12.21.01 255.255.255.0 IP Ospf1 area 0, and then interface gig 3/0 IP address is 10.12.12.1 255.255.255.0 IP Ospf1 area 0. Enter. Select memory. Now I'm going to paste this on all the routers. Sorry, I'm going to paste this on router 1. Boom. Oh, I forgot to put the loopback. Did I? No, I don't think so. So now, interface loopback 0 IP address 1.1.1.1. So one more time. Then I'm going to clear the Ospf clear IP Ospf process. The reason is I want the router ID to be 111. Okay, show IP Ospf. I should see the router ID. No, so let us go and manually change it. IP router Ospf1 router ID 1.1.1.1. All right, now let us move on to router 2's configuration. This is going to be 2 here, this is going to be 2 here, and this is also going to be 2. That's all, there is nothing more to do. Alright, now we are going to see the default. Let's see the default. Show IP route Ospf. No route so far, wait. We got neighbor. Okay, there are two neighbors here because this is serial, no. Via serial there is no DR/BDR. And this is for both Ethernet and Why fast Ethernet does not come? Let's wait. It will come. Something is wrong with fast Ethernet. Show IP interface brief. Maybe the interface is down. Yeah, see, the interface is down. Interface F0/0. No shit. Likewise on R1. Interface okay, show IP Ospf neighbor. Okay, 3 neighbors. Actually 1 neighbor, 2.2.2.2, but 3 parallel connections. This is in 2 ways, so I'm waiting. Start state now only. Okay, loading full. Alright, now let's check the routing table. Show IP route Ospf. You see, it says I'm going via gig and fast Ethernet. You know why? Serial is 1.5 meg only, just 1.5. Now via gig Ethernet and fast Ethernet, the cost is same. That's what I was talking about. The loopback interface cost is 1 and gig Ethernet cost is 1. Wait, let me draw it more clearly for you. Oh no. You got 3 links. 1, 2, 3. This is 1.5 meg only. This is 1000 meg. This is 100 meg. For this, both the cost is going to be same. For this, it will be lower, so it ignored this path. But these two are seen as equal, which should not be. Okay, that's one story. The other story is you can manually configure the cost. So now what I'm going to do, I'm going to configure the cost manually so that serial will be preferred, these two will not be preferred. Let me do that. I'll go to interface gig 3/0, IP Ospf cost 1000, interface F0/0, IP Ospf cost 1000. And then I'll go to router 2 also and say interface gig 3/0. I'm trying to make that serial interface as better cost than fast Ethernet. Now let's verify. Show IP route Ospf. See, only one route via serial. Only via serial. Both gig Ethernet and fast Ethernet has become bad. Show IP route Ospf. It is only serial. Serial cost is only 65. But what is the cost I have given for gig and fast Ethernet? 1000. Which is too high. So manually like this you can go and do tuning. This is how network architect play with the protocol. Now let us go back to the second learning. First learning is manually configuring the cost. Second is going and changing the numerator, the reference bandwidth. Now let us go and remove the cost that we manually configured. Now show IP route Ospf. You see, we got the routes back. And we got two routes. But these two are seen equal, which is not good. We want gig Ethernet only to be seen in the routing table, because this cost and this cost cannot be same, because the bandwidth is not same. This is the wide road, sorry, the broad road. This is very narrow, both cannot be same. So what we do, we are going to change the cost, the reference bandwidth. For that, I go and say router Ospf 1. See, auto cost. That's what I was telling from the beginning. Dynamically cost calculator, automatic. No, auto cost calculation. When you do automatic cost calculation, let your reference bandwidth be 10,000. If I give 10,000, what will happen? The cost on gig Ethernet will become 10 and fast Ethernet will become 1. No. Cost on gig Ethernet will become 10, fast Ethernet will become 1000. So here you will see 11. 10 plus the loopback cost 1, 11. So let me copy this and put it on the other router also. We have to configure this on all the routers. Router Ospf 1. Fine, finished. Now if you go back and check on R1, show IP route Ospf, you see you got only the route via gig Ethernet. As I said, the cost is 11. And that has brought us to the end of that chapter. In our next class, we'll move on to summarization in Ospf. Any question on what you learned today about the Ospf metric?
Yes.